So, hello everyone. I am A.E. Mallari, and I will be presenting the potentials for open source land use change simulation in local planning. No? So, this is a presentation for the Pista ng Mapa 2020. So, to introduce myself, I am A.E. Mallari again, and I'm a PhD student at the School of Urban and Regional Planning, the University of the Philippines. Uh, my dissertation is related to land use change simulation as a planning tool, and uh, I'm also a licensed environmental planner. And I've been involved with different research projects on climate change vulnerability assessment before, and also on land use planning projects. So for uh, today, I'll be presenting, I think, about 10 to 12 slides. No? So sige po, I might, before I start, I think I might go from English or also Taglish din po, no, for our viewers or our participants. Okay, so I think you better start, no? So, for the background and rationale, studies of land use change serve as a guide for policymakers in long-term urban planning. Recently, there have been emerging spatial models to aid land use planning, but this has been done in other countries, no, for most of the researches. And the simulation of land use change, according to several authors, is important for planning and management issues, since uh, these models can provide baseline scenarios to show the future land development patterns. So I think as planners, we need to know the future conditions so that we would be able to create plans, programs, and policies that uh, consider the consequences of land use change. No? It's important to analyze the consequences of the land use change models. No? Okay, so these are some examples. This is a On the left you can see a simulated land use, and I think this is in China. So this was done in 2002, and on the right is a time series map using a software called Land Use Sim. No? This was done 2 years ago in 2018. So you can see it's almost 2 decades, and there have been already a lot of research is done before, no? And until now, no, on land use change simulation. I think it's very relevant in times right now. So this is just a list of the models of land use change. So first is the I won't go through these models by detail, no, because they're very technical in nature, and some of them I'm also still learning about them. No? But these are some of the models that have been mentioned by authors of land use change simulation, and they include statistical and econometric models, spatial interaction models, optimization models, cellular automata, agent-based models, rule-based models, stochastic models, dynamic models, fluid modeling framework, microsimulation, and hybrid models. For as an example, I mean, for this presentation, the example that would be studied is spatial in nature, because we're talking about open source mapping software, no? So it's important to have a spatial component. And okay, I think I will show later an example of the land use change simulation tool. No? So here in the Philippines, there have actually been researches done to study the land use change, no? Or land cover change and simulation of these parameters. No? So to your left, you can see the landscape model in protected areas. This was done in the Sierra Madre region, and to your right is a CLUES model for forest areas in Sibuyan Island. So there have been authors who have done this now. So my apologies, but the references for these uh, screenshots will be shown in my last slide. No? So there, no. As I mentioned, there have been already studies or research is done uh, for land use change, but the question is, has the planning process adopted the uh, these researches no, into the comprehensive land use plans, which I will discuss later. Okay, so for this presentation, I will tackle an example. Uh, this is a land use change simulation example. So this is actually a tool or a plug-in extension for Quantum GIS. So the name of this tool is called Modules for Land Use Change Evaluation, or MOLUSCE. It's a shorter acronym for the software. And some of these features include that it is as I've mentioned earlier, it's an extension tool for Quantum GIS, which we know is an open source software. So I think this is the theme of Pista ng Mapa. There are actually, and I've actually used other land use simulation tools, but those require, yeah, they entail some costs. No, they're not for free, unlike this tool. Okay, so that's the advantage of this tool is it's open source software. It's part of Quantum GIS, so it's easily accessible, and it also has some features like it uses cellular automata for simulation, which is allocating the future land uses in the raster basis, and also it uses transition probability modeling, which I will explain in the next slides. No, and another feature which I haven't put in this slide, I'm sorry I forgot, is the integration of the spatial driving factor. No? So an assumption is that the future land use change is dependent on the proximity to a spatial driving factor. So, for example, in land use change developments, normally they, uh, for example, if we talk about built up areas, uh, common development is that they grow near existing built up areas already. That's why we have urban expansion, or they develop along roads or infrastructure for transportation access. Sometimes they also are near commercial areas for economic opportunities. So those are different examples of driving factors, which I will show in the example in a bit. Okay. So this is how the modules for land use change evaluation uh, is uh, is used. No, so this is a case which I've practiced no, using the software. No, I've done this a few years ago. So input to the Mollusque extension tool requires three major components. The first one is the initial land use. As you can see, the box on your left shows the how the extension tool looks like no, in QGIS. So as you can see, the first input is the initial land use. So it's 2010. So in TIFF format, it's in a raster, and this is it. No, it's the land use at period one. So we say, for example, 2010, and another input is the land use at year 1 plus x. No? So a number of years after the first time period, or the first period, sorry. So you can see this is a land use at year 2017. So for this example, this is actually a real land use shapefile from a barangay in a municipality. No? And the darker regions show the built-up areas. No? So it might not be that evident in your screens, but there's actually a change, no, from year one to year uh, one plus X, no. So there are developments along this portion, which are not here, no. So these are additional built-up areas. So you can see there has been a land use change. For example, there has been change from agricultural to built-up. Okay, the third input, which I mentioned in the previous slide, is this spatial driving factor. So for this exercise or this example, we will use the existing road network as a driving factor. This means that uh, the land use change will be most likely to occur along or near the road network of the municipality. No? So it will be likely to occur along the road network, no? So because it is used as a spatial driving factor. Okay, so here in the next slide, you will show how the land use change model or the extension tool for QGIS, how it works. No? So first, it generates a Markov transition probabilities model. Again, this is quite technical, but basically the Markov matrix shows the probability uh, of how one land use changes from one to another. No. So, for example, you can see there are four land use classes here: one, two, three, four, and there are values which are less than one. So this matrix shows the probabilities of one land use changing to another. So, for example, here in row 2 and column 1, there is a 0.013677. So this means that uh, the probability of the second land use category changing into the first land use category based on the two shape files or the two raster files that we've inputted is 1 point. It's just roughly 1%. No? So that's the meaning of the probability. No? Okay, so I think yes, this is quite technical, but as planners, I would leave the software or we can have another session for discussing this uh, model, no? Or the technical parts of the model. No? Okay, to your right, you can see that Mollusca provides four options or four model options, no, for the land use change. Again, this is again technical. No? So there's artificial neural network or ANN, weights of evidence, multi-criteria evaluation, and logistic regression. No? For this example, I used the artificial neural network as the model for land use change. And then after it, the model runs. So it will take about, depending on the capacity of your uh, laptop or PC, it will take some time to produce a simulated land use at a certain time period. So from there, the model shows, I think it simulates at 1 plus 2x. No? So for example, if the length between the first year of our shapefile and the second shapefile is around 6 years, automatically the software will simulate for another 6 years. No? Okay? So basically, this is the result of the simulation. It means for the next 6 years, this is how the land use of the barangay, looks like. No? So these are the built-up areas. And you can set constraints now, which is actually also the basis in the Markov transition probabilities. Okay, so it's quite technical. It can be challenging. There might be a lot of questions, but for the purpose of this presentation, I'll just show how the simulation tool works. No? Okay, so next question is can it be integrated into our current land use planning process? So, for those who are not familiar, the local governments here in the Philippines are mandated to update their comprehensive land use plans. No? So, basically, uh, results to a zoning ordinance which restricts the types of land uses being used in a certain area in the municipality or city. So, to come up with a comprehensive land use plan, you have to actually undergo a certain process, no, which is this, the one that you can see on your screen. And this process is available in uh, the CLUP guidebook created by the Housing and Land Use Regulatory Board. So the question is the land use change simulation already integrated in the planning process? So the answer is it is not yet, and that's why we are studying if there is a potential for the land use change simulation to be part of the land use planning process. And my answer is definitely yes. So as you can see in the figure, there are the 12 steps of creating the comprehensive land use plan, and the tool is most likely to be placed in analyzing step 4, which is analyzing the situation or the current land use trends, because that's what we've studied earlier, and step 6, which is establishing development thrusts and spatial strategies, which I've mentioned in my first slide. Authors of land use change models see the how the simulation tools are applicable in creating baseline scenarios, for spatial strategies. So these are the two steps in which the land use change simulation tools are applicable. So yes, this is an example of projecting land use demand and establishing historical land use trends from the guidebook. Actually, there is already a basis now for allocating future land use requirements, but I think the improvement brought upon by the simulation tool is that it provides a spatial aspect. So for example, we know that, for example, we projected the built up areas to be 100 hectares based on several parameters such as the future population, the future demand, etc. But for these 100 hectares, where do we allocate them? And this is where the land use change simulation tools come into play, no? So they can provide a picture of where the 100 hectares is distributed, like what I've showed earlier in the barangay. Okay, so even though we see the potential of land use change simulation tools in planning, there are still issues and challenges to be faced. No? And these are some of the issues that I've thought to be relevant. No? The first is the technical capacity of local planners. So as we've seen, I think planners have not yet been really introduced in trying the simulation tools into their local land use plans now. So it's relatively a new practice. It's going to be a new practice here in the Philippines, and there is an amount of training needed for since the simulation tool is very technical in nature. So the next issue is actually financial constraints for local government units. So, but this can go both ways now, because the example that I showed, Molluske, it's a open source software, so the financial constraints might just focus on the training, but there are some land use change models which entail costs, no? But again, I mean, for this presentation, the purpose was to uh, really explore the potentials for the open source mapping software, no? So yes, and the third issue is the willingness of the planners this should be to adopt new tools and methods, no? So are they willing to adopt the the land use change simulation and incorporation of their local plans, no? Since it's again a new practice, there might be some resistance or some hesitations. Again, these are some issues and challenges that I myself am also still learning the answers to these questions, to these issues. Okay, so that's actually the end of my presentation. This is the list of references that I've used. So ayan, you can see here the Philippine application. These are the references that I've used. I mean that where I got the pictures from. No? So we can take probably screenshot it. And that's all. So I think it's almost time. It's roughly about 2 to 3 minutes left. But yes, I think if you want to have a further discussion on land use change models, or yes, you can send me an email. I'll provide my email to the organizers of this uh, conference. No? And I hope that you learned a bit about the potentials for open source land use change simulation. Salamat po. Thank you very much. Have a good day.